Hello students, in this class we are going to start new chapter from organic chemistry part. The chapter name is Aromatic Amines. Aromatic Amines, and here first we have to discuss the definition for amines. What are amines? See, these amines are the organic compounds derived from ammonia, which is having the formula NH3. Organic compounds derived from ammonia are called amines. What are amines? These are the organic compounds derived from ammonia. Okay, or we can give other definition for amines. Amines are the alkyl, aryl, or uralkyl. Amines are the alkyl, aryl, or uralkyl derivatives of ammonia. Okay, these two are the definitions for amines. And coming to the classification of amines, these amines are classified into different types depending on the these amines are classified into different types depending on the three factors. The first one is what? Depending on the number of hydrogen atoms of ammonia replaced. First one type of classification is depending on the number of hydrogen atoms of ammonia replaced. The second one classification is depending on the nature of substituents in the amine. And the third one and the last one classification is depending on the type of substituents which are present in the amine. Type of substituents which are present in the amine. Okay, we are dividing or we are classifying the amines depending on these three factors. And let me explain these classifications in detail one by one. First one, we have to discuss about the classification depending on the number of hydrogen atoms of ammonia replaced by the alkyl or aryl groups. Here these amines are classified into three types. These amines are classified into three types depending on the first factor, that is depending on the number of hydrogen atoms of ammonia which are replaced by the alkyl or aryl groups. These amines are classified as three types. The first one classification type depending on the number of hydrogen atoms replaced by alkyl or aryl groups is what? Primary amines. Okay, then what are primary amines? See, these are the amines in which one hydrogen atom of ammonia is replaced by alkyl or aryl group. One hydrogen atom of ammonia is replaced by alkyl or aryl group. And the general formula for these type of amines, that is the primary amines, is RNH2. RNH2, this is for alkyl amine. Here R stands for alkyl group, or we can write ARNH2 for aryl amine. Okay, take for example for these primary amines CH3NH2. This is an alkyl amine and its name is methyl amine. See here, one of the hydrogen of ammonia is replaced by alkyl group, therefore it is called a primary amine. Or we can write C2H5NH2. Here also one of the hydrogen is replaced by this C2H5 group, and it is an ethyl amine, which is an example for primary amine. For aryl amines we can take C6H5NH2. Here also one of the hydrogen is replaced by an aryl group, that is a phenyl group, and it is phenyl amine. In general we can call this one as an aniline. Okay, primary amines. And the second type of amines is what? Secondary amines, which can be represented by 2-degree amines. 2-degree amines. See, these are the amines in which two hydrogen atoms of ammonia are replaced by alkyl or aryl group. Alkyl or aryl groups. For this we can write the general formula R2NH, or we can write RNH R dash. These R's may be same or different. For aryl secondary amines we can write AR2NH, or we can write ARNH AR. Here we can easily see that two hydrogen atoms of ammonia are replaced by two aryl groups. Two hydrogens of ammonia are replaced by two alkyl groups. In case of primary amine, only one hydrogen is replaced. Okay, these are the general formulas for secondary amines. And for examples we can take CS3NHCH3. These R's are same here. Here two hydrogens are replaced by two methyl groups. Okay, it is dimethyl amine. Or we can take C2H5NH, C2H5. It is diethyl amine. Okay, or for aryls we can take C6H5NH, C6H5. For aryl secondary amines it is diphenyl amine. Okay, these are the examples for secondary amines. And the third type is tertiary amines, or we can call this one as a 3-degree amines. 3-degree amines. These are the amines in which in which 3 hydrogen atoms of ammonia are replaced by alkyl or aryl groups. 3 hydrogen atoms of ammonia are replaced by alkyl or aryl groups. See, the general formula for these tertiary amines is R3N, or we can write RN, R, R. This is the general formula for tertiary amines. See here, all the 3 hydrogens of ammonia are replaced by alkyl groups, and we can write AR3N or ARN, AR, AR. Okay. Coming to the examples, we can write CH3N, CS3, CS3. Here all the 3 hydrogens of ammonia are replaced by 3 methyl groups, and its name is trimethyl amine. For aryls, we can take C6H5N, C6H5, C6H5. Okay, it is triphenyl amine. Okay, these all 3 are the classifications of amines depending on the number of hydrogen atoms replaced. Depending on number of hydrogen atoms of ammonia replaced by the alkyl or aryl substituents. Okay, and next we have to discuss the classification depending on the nature, or we can write kind. What kind of substituents are they? Depending on the nature of groups attached. Depending on the nature of groups attached to the nitrogen atom, these amines are classified into 2 types. These amines are classified into 2 types. The first one type is what? Aliphatic amines. Aliphatic amines. See, depending on the nature or the kind of groups which are attached to the nitrogen atom of an amine, these amines are classified into 2 types. In that, the first one is aliphatic amine and the second one is aromatic amine. Okay, then what are these aliphatic amines? See, amines in which the nitrogen atom is directly attached to one or more number of alkyl groups. If in an amine the nitrogen atom is directly attached to one or more number of alkyl groups, then that amines are called what? Aliphatic amines. The general formula for aliphatic amines is RNH2. If only one hydrogen is replaced by an alkyl group, RNHR. If 2 hydrogen atoms are replaced by 2 alkyl groups, RNRR. If 3 hydrogen atoms of the ammonia are replaced by 3 alkyl groups. Okay, these all are the general formulas for aliphatic amines. And coming to the examples for this type of amine, we can write CH3NH2. This is methyl amine. For this type of amines, we can write CH3NH, CH3. dimethyl amine. Here CH3 N CH3 CH3. It is trimethyl amine. Okay, these are called what? Aliphatic amines. And the second one type is aromatic amines. See, again, these aromatic amines are classified of two types. Again, these are of two types. The first one is aryl amines. Second one is of uralkyl amines. First, we have to discuss this aryl amines. See, the amines in which the nitrogen atom is directly attached to one or more number of aryl groups. If the amines are containing a nitrogen atom which is attached directly to one or more number of aryl groups, then that amine is called aryl amine. The general formulas for these type of amines are ARNH2. When only one hydrogen is replaced by one aryl group, ARNHAR. When two hydrogens are replaced by two aryl groups, ARNHAR. When, sorry, this is not ARNAR. When three hydrogens of the ammonia are replaced by three aryl groups. Coming to the examples, C6H5NH2. See here, one of the hydrogen of ammonia is replaced by one aromatic, that is aryl phenyl ring. Therefore, it is called phenyl amine, and it is an example for aryl amines. Aryl amines. This is C6H5NH C6H5. This is a diphenyl amine. C6H5N C6H5 C6H5. This is triphenyl amine. Okay, these three are the examples for aryl amines. And here another type is there. The second type of aromatic amines is uralkyl amines. Uralkyl amines. See, these are the amines in which the nitrogen atom is attached to the side chains of one or more aromatic rings. These are the amines in which the nitrogen atom is attached to the side chains of one or more aromatic rings. For example, we can write C6H5 CH2NH2. Okay, this is benzyl amine, or we can write C6H5 CH2 twice NH. Here two hydrogens are replaced by the side chains of benzene ring. Dibenzyl amine C6H5 CH2 thrice N. This is tribenzyl amine. These three are the examples for uralkyl amines. When the hydrogen atom is replaced by the benzene ring which is having an R alkyl group, or we can say if the nitrogen atom of an amine is attached to a side chain of benzene ring or aromatic ring. Okay, then the last one classification, third one classification, depending on the type of substituent groups attached to the nitrogen atom. The third one classification is depending on the type of substituent groups which are attached to the nitrogen atom. These amines are classified into two types. The first one is simple amines. The second one is mixed amines. These simple amines are the amines in which identical groups are attached to the nitrogen atom. If same groups or identical groups are attached to the nitrogen atom, then those amines are called simple amines. For example, CH3 NHCH3 dimethyl amine, correct? Or we can take C2H5 NHC2H5 diethyl amine, or we can take CH3 NCH3 CH3 trimethyl amine, or we can take C6H5 NC6H5 C6H5 triphenyl amine. Okay, these are all the examples for simple amines. Please write down these names: diethyl amine, trimethyl amine, triphenyl amine. Okay. Then the second one classification is mixed amines. These are simple amines, mixed amines. These are just opposite to this one. These are the amines in which different groups are attached to the nitrogen atom. See if the groups which are attached to the nitrogen are different, like CH3NH C6H5. This is an aryl group, this is an alkyl group. Then these type of amines are called mixed amines. Mixed amines. Its name is methyl phenyl amine, or we can write CH3NH C2H5. Here one type of substituent is there, here other type of substituent is there. Therefore these are called mixed amines. It is ethyl methyl amine. Okay, these are all the different types of classification. See, apart from this classification, they explained about quaternary ammonium, quaternary ammonium compounds. See, these compounds are the derivatives of ammonium salts, in which all the 4 hydrogen atoms of ammonium ion are replaced by either same or different alkyl, aryl or uralkyl groups. See, these quaternary ammonium compounds are the derivatives of ammonium salt, in which all the 4 hydrogen atoms of ammonium ion, that is NH4 plus ion, are replaced by either same alkyl or aryl or uralkyl groups or different alkyl, aryl or uralkyl groups. Take for example CH3 4N plus I minus. As the compounds, here we have to write positive and negative ion, counter and center ion. This is what? Tetramethyl ammonium iodide. Tetramethyl ammonium iodide. See here, this is an ammonium ion in which all the 4 hydrogen atoms are replaced by same alkyl group. These are called quaternary ammonium compounds. Or we can write C6H5N CH3 plus Br minus. It is trimethyl phenyl ammonium bromide. Trimethyl phenyl ammonium bromide. Okay, this is all about quaternary ammonium compounds. Thank you.